Hello. Today's topic is estimating limits from a graph. And we're going to focus mainly on graphical representations of a function, both one-sided and two-sided limits, so you guys can see what that looks like. So I have a series of examples here. We're going to talk about the left, the right, the two-sided, and just straight up output of what the function is at a given x value. Okay, so for example 1 here, I give you a graph. The limit as x approaches 1 from the left is going to be this piece. Okay, so I want to know the y value that the left side of that graph is approaching. And so as I get closer and closer to 1, the left side is getting closer, the outputs are getting closer and closer to the output of 1. Now, likewise, as I get closer and closer on the right side, so the right-sided limit for part B is going to then approach the y values or the output of 2. Now, because the left and the right-sided limits are not equal, we can say for part C that the two-sided limit does not exist. As soon as my stylus starts working here. There we go. Okay, does not exist. Now, the last part D, is f of 1. So I actually want to know where the point is. So the limit doesn't actually indicate where the coordinate is. It just says what the graph is approaching. So what I want to do for this last part is I want to determine where the actual point is. And that's going to be where the filled in circle is. So that's going to be at 2 as well. All right, so for each of these, we have a left, a right, a two-sided, sometimes the output. So we'll kind of go from there. So let's do example 2. Feel free to pause and try to work these out if you need to. All right, you can check your answers along the way. So I want to know 1 from the left. So if I do 1 from the left side, that's going to be this side. So that's going to be a y value of -1. 1 from the right. Okay, so change colors here so you can see 1 from the right is going to approach a y value of +1. And then the two-sided limit, because those go to different values, those aren't equal, that does not exist. And then for the last part, the output at 1 is going to be where the filled in circle actually is. And that is going to be at the y value 0. Okay. If I can get my stylus working here. Hold on. Doesn't want to write. There we go. Okay, so I get a y value of 0. So example 3, we're going to do the same idea. The left side, okay, goes to a y value of 1. The right side is going to also go to the y value of 1. Now, because both of those are equal, my two-sided limit will also be 1. And then for the last part, what is f of 1? Because that's an open circle, it is undefined at 1, so therefore that does not exist. All right. Now, for the next example 4, the left-sided limit at 1. So as I get closer and closer to 1 on the left side, that's 1. From the right side, should probably change colors there. There we go, is 1. And the two-sided limit, because those are equal to, is also 1. And then f of 1, there's a little point down here. It's easy to miss, okay? There is a coordinate down here at the value of -2. All right. Example 5, 0. So as I approach 0 from the left, so as I get closer and closer to that y-axis, that is going to be at the value of 1. As I approach the x value of 0 from the right all right, there we go. That is also 1. As I approach the x value of 0 from both sides, you can see they're equal, so that will be a value of 1. And then where f of 0, so I actually want to know the output at 0. And even though there isn't like a point indicated, we all know that this is continuous at 0, so that would also be an output of 1. All right. Now, for example, 6 and 7, we have some asymptotes. So I want to take a look at those. So as I approach 2 from the left, right? So as I approach 2 from the left, this is going to go down forever. Now, as I get closer to that vertical asymptote, I don't actually hit it, and it's just going to keep going further and further down. So you can write for this, I will accept either negative infinity, or if you want to put does not exist, because it doesn't actually go to a discrete value. So I would accept either one of those. Okay. Now, likewise, if you approach 2 from the right, this is going to go to positive infinity. Or again, because it doesn't go to a discrete value, you can write does not exist. All right. And because those go to different places, the two-sided limit definitely does not exist. And at the vertical asymptote, there is no point identified, or it's undefined at that value. So lastly, since there is no point at x equals 2, this does not exist as well. Okay, so some variations. If you have an asymptote for a one-sided limit, I will accept either does not exist, or you can put infinity or negative infinity for those answers at a vertical asymptote. But the two-sided limit doesn't exist, and there is no point indicated at x equals 2, so therefore there is no output. Example 7. So at -2, change colors here. As I go closer and closer to -2 from the left, this is going to go to negative infinity. Here we go. Or again, like I said before, does not exist. I'll take either one of those. The right side also goes down to negative infinity, or you could write does not exist. Now, because both of those are technically going to negative infinity, I know you would know what you're referring to. You could say that, this two-sided limit, if you will, goes to negative infinity. But again, because that's not a specific value, it's not a concrete number, you can say it does not exist. And then lastly, what is the output at -2? Yeah, be careful because it is defined here. There is a point on that x-axis. So in that case, it would be 0. All right. Now, I have one graph, a lot of questions for one graph. So when we do this, we want to try to answer these. So if you want to pause, you can pause and try to answer all these questions on your own, and then just check your answers. I'm going to go through them one by one. So starting with part A, f of 0. So at 0, there is a hole there, so that does not exist. F of 2, so going down, is going to be at 0. So there is a point here on the x-axis. F of 3 is this point all the way up at the top. Part D, as I approach 0 from the left. So 0 from the left is going to be this section that is going to go to negative infinity. And like I said, I would also accept a does not exist here. As I approach 0. Now for part E, this is a two-sided limit. So from the left and from the right, those are not the same. So we have that definitely does not exist because the left and right side have to be the same in order for a two-sided limit to have a value. As I approach 3 from the right, I'm going to change colors here. So as I approach 3 from the right side, that is going to go to the y value of 2. As I approach 3, so again, the left and right are different values. You can see the left side goes to 1, the right side goes to 2, so this does not exist. And then lastly, as x approaches negative infinity, that's going to be this section over here. It's kind of going toward that horizontal asymptote, so my graph is going to get closer and closer and closer to the y value of 1. Okay. Now, the last part of my video here is going to be, can you do the opposite? Can I give you limit statements and can you sketch the graph? And this is more difficult for some people. Also, I want to indicate there is a small typo. If you look at 2 of these check marks, you can't have f of 3 defined at 2 different values. That's not a function then. So I do want to cross that off. And I want to try to sketch the graph with the remaining characteristics. Now, my strategy for this is to start with the points, start with the coordinates that we know. So like if you look ahead, I know f of -1 is 2. So at -1, I know I am going to put a point at 2. F of 3 is going to be at 4, right? So I know that these 2 points exist. All right, so that helps, kind of clue into where my graph is going to be. Now I kind of do these limit statements one by one. So I'm going to look at the first limit statement. The limit of f of x as x approaches -1 from the left has to be 2. So the left side is going to go to the value of 2. Okay. The right side, okay, so you notice I kind of put a little tail on the left side of that point. The right side is going to go to a value of 0. So at -1, I have to be at a y value of 0, and I'm going to put a little tail on that. So you can kind of see the left side is going to go to the output of 2 at the top here, and then the other side is going to go to 0. So that's how I do those 2 limit statements. Now, as I go to 3, this next limit statement is a 2-sided limit, which has to be at -1. Okay, so as I go to 3, I want to be at -1, which means I'm going to do a little something like that. And because it's a 2-sided limit, I want to keep going. And I get a graph that looks like this. Now, there is, again, a small typo here. You can't have 2 limits at the same x value. So what I want you to do on your paper is just cross those off. But this would be my graph with those limits. I apologize for the typos. I will make those corrections for future handouts. Okay? I do want to do this one more time, though. And I promise this one doesn't have any typos in it. I've already done it. Again, when I do this, I'm going to start with the points, the coordinates I know. At f of 1, I know I'm at 1. At -2, I'm also going to be at 1. So I check these off right away. I can put those coordinates. At 0, I know I'm going to be at -3. So you can kind of see where my graph is going to be located. All right, now I want to kind of piece together some stuff. So as x approaches -2, this is a 2-sided limit. All right, so from the left and from the right, I'm going to put tails on it. I know I need to approach that point from the left and the right to a y value of 1. As I approach 0, this is also a 2-sided limit. So now I'm looking at this, the limit right here. As I approach 0 from both sides, I know it has to go to the y value of -2. Okay. The problem, though, is I have a point at 3, or -3. So I need to go to this y value. So again, I'm going to put a tail at both ends at 0 and check that off. So I can kind of connect these tails together. Now, the limit as I approach 1 does not exist. So I can't have the 2-sided limit work. But as I approach 1 from the left, I know it has to go to -1. So it's going to go like that. And then the right can't be -1 because that limit can't exist. So I get a graph that looks like that. So again, I kind of double check. All my points are in the same place. -2 from the left and right goes to a y value of 1. 0 from the left and the right goes to a y value of -2. And then the limit at 1 does not exist with the left hand side going to the y value of -1. So that would be my graph. Now, the goal here is if I give you a graph, you can evaluate limit statements, one-sided and two-sided. And then if I give you the limit statements, you can create the graph. Okay, and we'll do more practice with this, but here are some examples to kind of learn how to do it.